So in this video, I'm going to solve a problem about a baseball diamond, which you can see given here. And I'm going to start by figuring out what the given information is. So there are a couple pieces of information given in the question. First is that the diamond is a square shape with dimensions of 90 feet on each side, so 90 feet between the bases. And that's labeled between first and second on the diagram, but I can also label it on the other dimensions as well. Because it's a square, all the sides will be equal. Another piece of information that's given to us is that the catcher can throw the baseball at a speed of 70 miles per hour. So the speed of the throw is 70 miles per hour. And what we're trying to find is the time it takes, how many seconds it takes for the ball to travel from home to second. So what we're trying to find is the time for the throw from home to second. And I'm going to make a bit of an estimate for how long this will take. I've watched some baseball on TV, so I think that it will take about 2 seconds. So I'm estimating that for the ball to get from home to second, catcher throws it. I can imagine counting to 2 as it goes from home to second, so I'm going to say about 2 seconds. Seems reasonable to me. Now, in terms of solving it, I already have a strategy in my mind that I can use to solve this problem. And that is an algebraic strategy that involves a formula. And that formula is speed equals distance over time. And I just know this from my work in previous years and in science class and in math class. So there we go. This is perfect. I'm looking for time. I know the speed. And now I've just realized that I don't know the distance. So this strategy won't work right off the bat and perhaps isn't enough to help me solve this problem. So the problem is I need to actually find the distance. That's a piece of information I don't know that I need to find. I got kind of stuck here, but I went to see Miss Fielch for some extra help, and she reminded me of a strategy called the Pythagorean theorem. That is a way to find distances in triangles. And I realized that if I label the distance I'm looking for, so the distance from home plate to second base, on my diagram, let's call that D. So I'm going to write a let statement for that. Let D be distance from home to second. If I label that on my diagram, I can see on the right-hand side of the diagram, a triangle is kind of formed between home, first, and second. So I'm going to use this strategy Miss Fielch told me about, but first I'm going to draw a diagram to help me execute the strategy. So here's a diagram. I've rotated the triangle a bit. This is another strategy I'm using. I'm going to label D is distance from home to second. So this would be the home plate corner. This would be first base corner, and this would be second base corner. And of course, I already know that it's distances of 90 feet between each of the bases. So now I have a triangle set up in a way that I can use the Pythagorean theorem. So I remembered after Miss Fielch helped me out that the equation for the Pythagorean theorem is that the square of the hypotenuse, and the hypotenuse is the side opposite the right angle, so here's the right angle, here's D, D squared will be equal to the sum of the squares, the other two sides. So D squared equals 90 squared plus 90 squared. That gives me 8100 plus 8100. And then I get D squared equals 16,200. Not quite done yet, though, because I need to find D, not D squared. And the way I do that is I take the square root, the opposite of squaring something, and I apply that to both sides. So I get D is approximately equal to, I'm going to use proper notation for rounding, 127 feet. So that's the distance from home to second. So that's great because my algebraic strategy needed the distance, and now I found it. So I'm going to go back to that equation. Speed equals distance over time. And now I know that distance is equal to 127 feet, and speed, as given earlier in the question, is equal to 70 miles per hour. However, these are two different units. Distance is in feet, speed is in miles per hour. So before I use this formula, I need to actually convert the speed. So I have to go to Google. And Google will tell me the length or conversion between a mile and feet. So there, 1 mile is 5,280 feet. So in 70 miles, so if I have 70 miles per hour, in 70 miles, I'm going to have to multiply that by 5,280 feet per mile. So for every 1 mile, 5,280 feet. I can cancel out the miles units, and then I get 369,600 feet per hour for the speed. Okay, so I found the distance, converted the units for the speed. Now I can actually use the equation. So speed equals distance over time. Time is what I'm trying to isolate. So before I substitute in some values, I'm actually going to rearrange my equation, again using some algebra. So I need to isolate time. So first, I need to deal with the fraction. So I'm going to multiply this side by time. So that becomes time over time, which cancels out to 1 over 1. But if I multiply the right side by time, I have to do the same to the left. So then I get distance. I'm just going to flip this around. No, I'm not going to flip that around. So then I'm left with time multiplied by speed equals distance. And I still want to isolate time, so I'm going to divide out speed. And that's the same really as 1 divided by 1, but I have to apply it to the other side as well. So time is equal to distance over speed. Now I can substitute in the values I know. So time is equal to 127 feet, which is distance, over 369,600 feet per hour. My feet will cancel out, and I'm left with time is 0.000344 hours. Tempting to think I'm done, but I'm actually not, because if we go back to the question, it's asking for a response in seconds. So I've used an algebraic strategy, I've used a diagram, used another algebraic strategy, which is the Pythagorean theorem, calculated the time, but now I need to actually do a unit conversion to be able to properly answer the question. So time is 0.000344 hours. I know there's 60 minutes in an hour, so I'm going to multiply this by 60 minutes per hour. My hours will cancel out, and that will leave me an answer in minutes, but that's still not enough. I also know 60 seconds a minute. So my minutes will cancel out, and if I execute this, 0.000344 times 60, then I get my final answer. Again, proper notation because I rounded, 1.24 seconds. So that's my final answer. Therefore, the time for the throw from home to second is approximately 1.24 seconds. So now I've solved the problem. I've summarized or stated my solution. And this kind of makes sense. So when I think about whether this is a realistic answer, I would say yes, it makes sense. My estimate was 2 seconds, and my actual answer was 1.24 seconds, and that makes sense because, again, you wouldn't expect it to take very long to throw a ball from home to second, especially if it's traveling so quickly. 70 miles per hour seems pretty fast, so this makes sense to me, and I'm happy that that's a reasonable answer to the question. So I used Google to help me with my unit conversion, got my final answer, and there's the solution to the problem.